Hi everyone, welcome back. I hope y'all are doing great today. And I want to start off by asking you a question. What did the acorn say when it grew up? Gee, I'm a tree. I think that'll give you an idea of what our lesson is going to be about today. And that is that we are on Module 2, Lesson Chapter 9, Geometric Figures. So let's get started. For problem 1, we are given this figure, and it is asking us to demonstrate the relationship between the measures of angles 1 through 12. The way we're going to do that is by identifying the different types of supplementary, complementary, and similar angles that we have in this figure. But if you're like me, you've probably forgotten what those angles are. Therefore, let's take a little review. And so the very first one that we are going to talk about today is going to be supplementary angles. And supplementary angles refers to the sum of two angles adding up to be 180 degrees. Next, we're going to talk about vertical angles as well. And vertical angles are two angles who are on opposite sides of each other and whose measures are going to be equal. And complementary angles. Complementary angles refers to the sum of two angles being 90 degrees. Okay, so this is our first figure, and what's here is the information that has already been given to us. And so what we're going to do is we're going to identify the rest of these angles, but we're going to take it in sections so that we don't get confused. So we'll go ahead and start off with this bottom left-hand side. And we are given that this angle measures 63 degrees. And we can see that angle 6 is going to be supplementary to this angle. That means that this angle plus this will be 180 degrees. So the easiest way is to take 180 degrees and subtract 63 degrees to give us our angle 6, which measures 117 degrees. Now we see, okay, so we see that angle 10 is going to be on the opposite side of angle 6, which means it's a vertical angle, and vertical angles are equal. Therefore, angle 10 is also 117 degrees. Now we can see that our angle 9 is also on the opposite side to our angle measure of 63 degrees. Once again, opposite ones are going to be same. So angle 9 is 63 degrees. So now we have this bottom part of our figure calculated, so we'll go ahead and move on to the top part. And here we are given that this angle measures 58 degrees. So we see that angle 2 is on the opposite side. And once again, opposite angles are equal. Therefore, our angle 2 is going to be 58 degrees. Let's move on to angle 4. Angle 4 is corresponding to angle 9. What do we know about corresponding angles? That is that they are the same. Therefore, angle 4 is also going to be 63 degrees. Now, we see that, okay, angle 3 is opposite to angle 4. What are opposite angles? They are equal. Therefore, our angle 3 must be 63 degrees. Okay, so now let's look at this part. We see this line right here, and then we see that we've got two transversal lines, and we've got two angles figured out. So we have that this angle is 63 degrees, and angle 2 is 58. Now we want to know, well, what is the measure of angle 1? So if these three have to equal 180 degrees, all we'll do is take 180 degrees and subtract 58 degrees minus 63 degrees, and that'll give us that angle 1 is 59 degrees. Once again, we see that our angle 5 is on the opposite side. It's its vertical angle. That means that the measure of angle 5 also has to equal 59 degrees. Correct? Perfect. Now that we have this part solved, we'll move on to our last section of our figure. And here we see, oh, okay, we see that angle 12 is going to be the same as angle 5. And why is that? That's because they are corresponding angles, and corresponding angles are equal. That means angle 12 is 59 degrees. Perfect. Now we see that angle 7 is vertical to our angle 12 and will also be 59 degrees. And then once again, here we see that angle 7 and angle 8 are going to be supplementary angles. And supplementary angles are going to add up to 180 degrees. So 180 degrees minus our 59 degrees will give us the measure of 121 degrees. And lastly, we see that our angle 11 is going to be on the opposite side of our angle 8, making them equal vertical. Therefore, our measure for angle 11 will also be 121 degrees. Perfect. So this is going to be our summarization of our different angles that we just discovered in the previous form. And as we can see, we had no complementary angles. And why is that? That's because in our graph that we were given, our figure, we had no two angles whose sum added up to be 90 degrees. And therefore, we have 0. Moving on to problem number 2, we are asked to construct triangle ABC, and then it also wants us to add line PQ to make it parallel to our line AB, which means that those two lines will never touch. And then it wants us to make line RQ parallel to our line AC, meaning those will never touch as well. And then we are given this information and what these angles are, and it would like for us to also determine what are the angles, the measure of the rest of the angles in this figure. Once again, the way we're going to do that is by identifying the different types of supplementary, complementary, and similar angles. So the first thing we have here is we see that we have triangle ACB, and we know that the interior angles of a triangle have to equal 180 degrees, correct? All right, so we already have 2 of our angle measures determined. That means that we'll take 180 degrees and subtract our 63 degrees and our 36 degrees to give us 81 degrees for our angle 1 measure. Next, we're like, okay, we see that angle 1 corresponds to angle 3, which means that they will be equal. Therefore, angle 3 is also 81 degrees. Next, we see that on this line here, these two, angle 2 and angle 3, are going to be supplementary. Therefore, supplementary angles have to equal 180 degrees. What is 180 minus 81 degrees? 99 degrees for our measure 2. Now we see, wait, we have a parallelogram. What do we know about parallelograms? We know that their opposite interior angles are going to be equal. So that means that our angle 1 is going to be equal to its opposite angle 5. That means that angle 5 will also be 81 degrees. Same thing for angle 7. Angle 7 is the opposite of angle 2, and therefore it will also be 99 degrees. Now let's go ahead and move on to our angle 8. So we see that angle 7 is supplementary to angle 8. So we will take 180 degrees and subtract the 99 degrees, and that is how we got 81 degrees for our angle 8. Next, we'll move on to our angle 4. And we see that our angle 4 is going to be corresponding to our angle B, 36 degrees. Therefore, it'll be the same thing. And then finally, for our angle 6, we see that it also corresponds to angle C, and therefore this one will always also be 63 degrees. And on these, the way we can check is once we add up 63 plus 81 plus 36, it has to equal 180 degrees because that is the sum of our interior angles of a triangle. And then once again, we have created our chart to represent everything that we just talked about, showing our supplementary angles, our similar angles, and our complementary angles. And once again, why do we not have complementary angles in this figure? That's because we don't have any two angles who add up to be 90 degrees in this figure. Okay, so for problem number 3, it is instructing us to build a concave polygon. Okay, so this is our polygon, and it wants us to identify the measures of all of its angles. And the way that we're going to do that is we're going to use our formula for our interior angles. And that is represented by n minus 2 times 180 degrees. N represents the number of sides that our polygon has. So the first thing we'll do is identify the number of sides. So let's count them, shall we? We have 1, 2, 3, 4, 5, 6, 7, and 8. So we have eight sides to this polygon. So all we'll go ahead and do is plug that into our formula, and that'll give us that our sum of our interior angles, once we know what they are, will be 1,080 degrees. And so the next part that we'll do is we're going to identify for our variable, what is y? Therefore, we'll take all of our numbers in the polygon and we'll set them equal to 1,080 degrees, and that'll solve for our y variable. And it gives us that y is equal to 20 degrees. And then the next thing that we'll do is we'll go ahead and plug in our 20 degrees into our variables. So we'll start off with 3y is equal to 60 degrees, 7y will equal 140 degrees, and 12y will equal 240 degrees. And so we went ahead and labeled all of our angles. And if we wanted to double check and make sure that we have this correct, all we do is add up all of these numbers, and we will see that they all equal 1,080 degrees. Okay, so now we move on to problem number 4. And on problem number 4, it wants us to construct a regular nonagon. That means that our figure will have 9 equal sides. So we'll start building one side, 2, 3, 4, 5, 6, 7, 8, and 9. And we see that it's regular because all of the sides are going to be equal. Okay, and then we have our central angle here. And the first thing we're going to find out is what is the measure of our interior angle. And the way we are going to do that is by using our formula. Our formula for an interior angle is given as n minus 2 times 180 divided by n. Once again, n represents the number of sides. And how many sides do we have in a nonagon? We have 9 sides. So once we plug that into our formula, it gives us that our interior angle, which is the angle located inside of our nonagon, is going to be 140 degrees. Next, we want to solve for our exterior angle. And for our exterior angle, we can do 2 things. I'll show you those 2 things. Let's start with the first way. We have our formula for exterior angle, and that's going to be 360 degrees divided by n, which represents the number of sides in our polygon, which is 9. So that means that our exterior angle is 40 degrees. Also, did you know that interior angles and exterior angles are supplementary angles? Therefore, we could have actually done 180 degrees minus 140 degrees, and that would have also given us our exterior angle measure of 40 degrees. And then lastly, we want to solve for our central angle. And our central angle is this angle located here, whose adjacent sides meet at this vertex right here. And the way we do that is we will actually use the same formula that we use for our exterior angles. And that is 360 divided by n, which is 9 number of sides. And that'll give us that our central angle is going to be 40 degrees. Okay, problem number 5. It wants us to build a cube with the vertices A, B, C, D, E, F, G, and H. And this is our cube right here. And a cube is simply a 3D solid. As we can see, this is a 3D figure with 6 square faces. And then the next thing it wants us to do is it wants us to add the vertices D, E, G, and H. And we have done that so that you can distinguish the differences. And then the next part of this problem asks us that it wants us to construct a tetrahedron inside of our cube with its vertexes at D, E, G, and H. But it has one rule, and that is that it does not want any of the faces of our tetrahedron to show in the faces of our cube. And so the way we'll do that is we'll go ahead and build our tetrahedron first. And we're going to construct that. And that's going to be of 3 triangles put together meeting at one vertex, which is going to be right here. And we have to be able to put this tetrahedron into our cube without it obstructing the faces of our cube. And we'll go ahead and put that in. And as we can see, we are just good to go because none of the faces are actually within one single face. As we can see, it cuts it off. Therefore, we are good to go. Okay, y'all. And lastly, we have number 6. And for problem number 6, it is asking us to build a Schlegel diagram of a tetrahedron. And this diagram means that we'll be able to see through our tetrahedron. And what is a tetrahedron? So with this one, it's going to have 6 edges. So we'll start off by doing the edges of our shape. And the edges refers to the line segments that connect our figure. So we'll have those 6 edges. And then it is also identified that it has 4 vertices or 4 points where they all meet. 1, 2, 3, and 4. And then it has 4 faces. So we have 1 face, 2, 3. And then our 4th one will be located at the bottom of our tetrahedron. And that's the side that is not visible at the moment, but it is there. And then here's kind of a 3D model of our tetrahedron so that you can see all 4 faces of our shape. Okay, so the next one, we are doing the exact same thing. We're doing a diagram, but for an octahedron. And an octahedron is going to be characterized by having 12 edges. So we have to build our shape with 12 segments. So we'll go ahead and begin with 1 segment. There's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So far, so good. We have the 12, it has the 12 edges that our octahedron requires. The next thing is that it has to have 6 vertices. So let's see if we have that correct. There's 1, 2, 3, 4, 5, and 6. And as we can see, we have that correct because all of our edges here connect at these 6 vertices. And then the final characteristic is that our octahedron is going to have 8 faces. So let's see if we have 8 faces. We have 1, 2, 3, 4, 5, 6, and 7. And then, of course, our 8th face is going to be located on the bottom side of our tetrahedron, and we would be able to see that in a 3D model. But we see that we have all the requirements for an octahedron. And lastly, it asks for the diagram of an icosahedron. And an icosahedron is determined by having 30 edges. So we have to make the skeletal diagram of this with 30 edges. So let's begin by building it. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So we've got the 30 segments that build our icosahedron. And then the next thing is that it has to have 12 vertices. So let's go ahead and put our vertices and let's count them. There's our first one, second, third, fourth, fifth. There's our sixth one, 7, 8, 9, 10, 11, and 12. And as we can see, we have this correct because all of our segments meet at these vertices. And then the final part of the icosahedron is that it has to have 20 faces. So let's see if we have the 20 faces in our figure. And we'll count those out. As we can see, there's 9, 10, and we've got 15, 16, 17, 18, 19, and then 20. Our 20th face is going to be located on the bottom side of our icosahedron as well. And this is just a 3D model to let us get a better look at what it looks like. Okay, everyone. Well, that is it for our lesson. I hope that y'all enjoyed everything and that y'all learned a little bit more. Thank you for listening, and I'll see y'all next time. Bye.